Welcome, welcome, welcome to National Astronomy Week. Today it is day 8, and we have got an Orion and Sirius special. So, all week we have been chasing the moon across the sky. We've had events, downloadable resources, storytelling, and this is the second to last in a sequence of videos. And tonight we have got a feast of the heavens for you. This event runs from the 1st to the 9th of February, and it's supported by the Royal Astronomical Society, the British Astronomical Association, the Federation of Astronomical Societies, and the Society for Popular Astronomy. So hello everybody. And we are joined by, well, who are we going to have first up? James. Where's James?
Hello.
Hello, James. James, you're trying to outshirt me, and I'm afraid you don't have the spangly pants on. I don't believe so.
No, sorry.
Letting the side down there. Sorry, but yeah, that's a decent shirt. Where are you tonight, James?
Nottingham,
Excellent. And what are you going to be telling us about tonight?
the constellation of Orion.
Which is literally our raison d'etre. So, yeah, Orion looking very proud in the night sky at the minute, although he is getting a little bit lower and descending into summer. Beautiful, recognizable, easy constellation. But do you know what's actually inside Orion? Because Orion is just a feast, an absolute unbelievable amount of stuff going on. So we're going to go deep on Orion now. So let's have it. James, give it us with both barrels, please.
Super. Well, good evening. Hello from Nottingham. We're meant to be at the observatory, but unfortunately, the observatory is the all sky camera. We've got cloud and rain. So I took this image 5 minutes ago. The colours aren't aurora, like they're LEDs inside, which we still need to turn off. So Orion, lovely constellation, probably the most obvious constellation, looking south from the northern hemisphere. And I've highlighted the main stars here. So this is a photo I took some time ago. It's a much wider photo, which I've cropped in for this presentation, and you can see there's four sort of corner stars and three stars forming the belt, and the belt is the thing most people will notice. Now, a lot of stars have got names. I meant to look up how many stars actually do have names. Um, it will be several hundred, and they've all got strange origins. But the four main stars of Orion are called Betelgeuse, top left. Some people say Betelgeuse, Bellatrix, top right, Safe, bottom left, and Rigel, bottom right. And Vicky, if you ever want to pop in and ask questions, don't worry, just do that. And I knew Vicky would also want to know if the belt stars had names, and they do.
I think I
Uh,
do know them. Oh, you've spoilt it now because it took me about a month to learn them. But yeah, I do actually know what they're called. So yeah, go for it.
so from left to right, we've got Alnitak, Alnilam, and Mintaka. So here's another picture I took of Orion. Again, as part, I like wide field pictures of landscapes and stars. And so again, I've cropped this so it looks a bit odd. And I've put some flashing stars to show the outline of the constellation. And you can see the stars. And we use the belt to find other features in the sky. And if we follow the belt down, it points to the star Sirius, the dog star in the constellation of Canis Major. And if we follow the belt upwards, it goes to Aldebaran or Aldebaran. I'm not sure how it should be pronounced in the constellation of Taurus, and that's very close to the Hyades or part of the Hyades, a lovely open cluster. Um, you might wonder why I've given these stars, they're blobs anyway, colours, and it's because I've got a star trail I did here in from 2013, and star trails are pretty in their own right, but they also pull out the colours of stars, different colours. And you can see here, top left, Betelgeuse. The streak from Betelgeuse is yellowish, and Rigel, bottom right, is much whiter, brighter. and the others are sort of um, bluey white in color. And this star trail is just probably an hour to 2 hours. It's with a DSLR camera fixed on a tripod, and it takes 20, 30-second exposures continuously. And then free software can get those exposures and stack them and make a star trail. And I love star trails. So this is looking south. So the stars will appear to streak across the sky. And if you look at the north, the pole star, the stars will form a ring like the ring behind me. And if I move my head, you can probably just see Polaris in the center. So thinking a bit about the colors of stars, Betelgeuse is a red supergiant, which is partly why, well, mostly why it looks orangey red in color. Um, and its alternative name is Alpha Orionis, so the alpha star of Orion. Bellatrix and Saiph are blue type B stars, and they're Gamma and Kappa Orionis. And Rigel, bottom right, is also a B type star, and is called, other name is Beta Orionis. Now, interestingly, in constellations, the alpha star is the brightest star. But in Orion, the brightest star is not Betelgeuse, it is actually Rigel. So although Rigel is Beta Orionis, it should be Alpha Orionis. And there's discussions about how the two got the wrong names. Betelgeuse is a variable star. It recently went through, a couple of years ago, a dimming phase. And maybe one of the other speakers might mention something about that. But it's probably just an error when they named it. Now, I've done another drawing in 3D paint. I need to come out of the slideshow and make that a bit bigger. And what if we imagine this is how we see the constellation of Orion? But actually, those stars are not related to each other. It's just a line of sight effect. And I've put these stars at their rough distances away from the sun and Earth, and you can see some of them. If the sun's down here, um, in fact, I need to rotate that a bit like that. If the sun's down here, um, this star, which is Bellatrix, is the closest, and then Betelgeuse, and then the belt stars are much further away, and they're about 1,300 light years away, and Bellatrix is only 250 light years away.
James, are the belt stars related?
Probably not. It's just a coincidence that they're near one another or nearer each other than the others, if that makes sense. And there's the rough distances. I've rounded these up before we get any letters in of complaints, and no error bars. So go back to the I've lost my slides. Oh no, there we are. Go back to the star trail. Um, and what you can also do when you've taken lots of exposures is make a time-lapse video. And hopefully this is that same data from 2013 has been stacked into a video. And you can see the constellation of Orion drifting across the southern horizon. And you can see it points up to Aldebaran there, and Sirius might just be visible through the trees. And then invariably, cloud comes in, as always happens. Thinking about the constellation of Orion, there's also the sword hanging down from the belt. And if you look through binoculars, you'll see a fuzzy thing. And that is what the fuzzy thing is. That's the Orion Nebula. It left my mind for a moment. And in the mid 1800s, George Phillips Bond, an American astronomer from Massachusetts. I'm waiting for Vicky to sing the Bee Gees song.
Oh, right. Yeah, I don't know that one actually, but I was singing How Deep Is Your Love in the shower today, so would that do?
Um, So this George Phillips Bond for a 15-inch scope at the Orion Nebula, and he did this amazing drawing. Um, and what I've done is I've blown up my awful image of the Orion Nebula, and you can, if I flick between the two, you can see the similarities. Um, he spotted so much detail and shapes within the nebulosity. Um, I'm just amazed by that. Um, and I think that's about my roundup of the basics of Orion.
Thank you for that basic but very illuminating talk about possibly the best constellation. Come on, let's face it. It's got to be Orion. Hand it to Orion. So, James, we might come back with you in a little bit, but in the meanwhile, you can take your shirt elsewhere and sit quietly in the green room. And we're going to go over to Trevor now.
Yeah, good evening, everyone.
Good evening, Trevor.
Yeah, just like James beforehand, there was a bit of a clearance earlier on tonight. I'm on the south coast, and I thought, oh yes, we might be able to get something tonight, but sadly it's clouded over. So presentation time it is, I'm afraid.
Yeah, sorry about that, everybody, but have a word with God if you, well, have a word with the weather. We should have had wonderful live telescope views. We were all set up to go, but thankfully, the astronomers have done some excellent presentations. So let's go, Trevor.
Okay, right. So hopefully you can see my screen, and you should be able to see the presentation. Is that right?
All
Can
good.
you- Oh, good. Okay, I mentioned earlier on in these presentations this week that I'm mainly a visual observer of objects, mostly deep sky objects, and the subject that I spent most time in my latter years has been the Herschel 400 list, and I started that way back in April 2015, and I made use of this book here, which you can see Stephen O'Meara's book on the Herschel 400 Observing Guide, and I said, right, well, he started with a 4-inch refractor. That's what I'm going to do. So I started off with a Skywatcher ED 100 and put it up to the first object. First object was NGC 0040, the bow tie nebula in Cepheus, and I thought, oh, this is going to be good. And the next object I went to happened to be at the end of the coat hanger cluster in just in the Summer Triangle. And I was in very dark skies in North Yorkshire, very close to the coast, no light pollution at all, but I couldn't see this object. And so I thought, oh, I'm going to need a bigger telescope. And that became the sort of theme during the whole of my time on the Herschel 400. I was very lucky and I managed to swap my 4-inch for a 5-inch. Somebody had bought a 5-inch, found it too big, and we met somewhere on the M25 at a service station and swapped. And I drove up and started using that. And all the observations in Orion were done with that one. And they're both about the same focal length. So the 5-inch was a bit brighter because it's obviously got a slightly faster F number. So moving on then, I realized that that wasn't going to be good enough. Stephen O'Meara's role was to tell me that he could do everything with the 4-inch. But then I looked where he did his observing from, and he lives in a place called Volcano, which is on a remote island very close to Hawaii, and he goes up the mountainside to see it. So he's got no light pollution, and he is quite high up, whereas, of course, excuse me, I'm very close to the coast. So I bought this particular light bridge on Christmas Day in 2016, and I felt sad for the seller at the time because he wanted to buy some presents for his kids, and it'd been made redundant, and so he had to get rid of this scope. But what was bad for him was good for me, and I used that for quite some time afterwards. That was a much bigger scope, obviously, than the 5-inch. And the nice thing about the Meade 16-inch is, and me being over 6 foot tall, I can stand up and do all the observations from it. Of course, as I moved on with time, I built an observatory, and I use the 8-inch, which you can see on the right, the RC 200 millimeter, which I used a lot for visual observing, and before I then started to use it just in the observatory. And recently, I've got myself a 10-inch Meade Smith Cassegrain type telescope. And of course a wide field camera, the 26C, which has been mentioned before as well. Still not seeing all the objects, all these very faint galaxies in places like Orion and such like. So I did go then for an even bigger telescope, a 20-inch, and so that's what I have at the moment. The scopes in the observatory and the big 20-inch. So I'm not actually in Chichester. I'm sort of just to the west of Bognor Regis, right on the coast, and the skies there are thought to be 20.6 magnitude arcs second squared, or Bortle 5 if you prefer that. But of course that's straight up at the zenith. Whereas I look out over the sea, which is about 50 meters away, and I have very enjoyable evenings looking out over the sea, listening to the waves crashing, and it's very pleasant. And of course, it's much darker out over the sea than it is looking straight up. Views to the north are terrible towards Chichester, but to the south they're really quite good. So to actually find these targets, then all of the targets I do manually. So not like plate solving and things like that, which a lot of people do nowadays. So everything had to be found, and you need guidance for that. So I use a program called Deep Sky Planner. It was developed by Phyllis Lang, lives in, I think, in America or Canada. And it's an astro planning program which can be used both by visual observers like myself and also imagers as well, if you want to. And it gives you a good target list. I'm not saying there's anything wrong with pictures of the Great Orion Nebula, but I do grow tired of seeing the millions and millions of the same thing that people take. But anyway, that's so we've got lots of objects, 400 in the Herschel 400, which I'm also imaging at this time. Now, William Herschel had his own nomenclature for these objects. The New General Catalogue is what most people would know them by, but Herschel did have and develop his own way of doing things, and those are luckily put into a Deep Sky Planner. Herschel 400 objects there in Orion, which we're going to have a look at in a second. But these are the classifications. He had 8 classifications. For things like bright nebula class 1 right the way down to class 8, coarsely scattered clusters of stars, of which one of them in the middle there, class 4, was planetary nebulae, which he wasn't quite sure whether they were planets or not, because they had a diameter disk he could actually see. And I'll show you one of those, hopefully a little bit in a few minutes. So Herschel developed his own sweeps, and he was looking at these objects, and object 32 is one of those, and those are his real notes. And from what I can see, I mean, I'm not an expert on his observations at all, but he seemed to keep pages for nebula 32, and then when he did a new observation of it, with almost exactly the same writing, it seems, he just did some more observations, which was very good. And Herschel Object 32 is a reflection nebula in Orion. So this is Deep Sky Planner. So what we'll do is we'll go over to Deep Sky Planner. I'll just stop this one for the second. How do I do that? I can't find Deep Sky Planner. It's on the target list somewhere. I should be able to bring something else up, I think, shouldn't I? Let's escape from that. Go to Deep Sky Planner. There it is. Yeah. Can you see that okay? Yep.
It's just a blank page.
Yeah, that's all right. Yep. So
All
Deep
right.
Sky Planner is pretty blank. So we need to find those objects. And this is the object planner. And so that brings up some details that you need to fill in. So generally what they are, have I observed them or not is going to be one of the things. What the magnitude is, what the size is, what the constellation is. And of course, I can't ignore that because we're only looking for Orion. So pop down to Orion, which is there. And object types, well, obviously we want all of those. Sky position, well, we want to know whether we can see them or not, what the date is, and the viewing time. We'll just ignore all of those and do a search. Oops, no catalog's been selected. Forgot to do that at the beginning. So there we go. I need to do the Herschel 400. It tells me off nicely. So there we are. There's the Herschel 400. And those are the 8 objects that are in the catalogue, all of which I have ticked off. As you can see here, I have observed them all. So if I didn't want to, if I don't want to look at them again, then obviously I would tick yes or no to the whether they're observed or not. And I mentioned Herschel 32, and there's Herschel 32, type 5. And we can have a look in a little bit more detail about that and go and find out what it looks like, which is this picture here. This comes from the Digital Sky Survey images, all in black and white, unfortunately. Or we can actually right-click on that and so show chart, and that should take me, I think, to this one here. There it is, and that takes me to Stellarium, and you can see that that's a bit of nebulosity reflection, and it's in Orion. We've just had a look at Orion. There's the 3 belt stars, so it's right on the edge of Orion constellation. That's this line here. Those have all been determined beforehand, and that puts us very close to Eridanus here, but that's where that object is. And if I was looking for that, I'd obviously have to go to these 3 stars, go down to here, and then across a little bit, and eventually till I find it, and then I tick it off. Going back to Deep Sky Planner, I would then say, well, have I done the observations of that? So I'd probably go into my observing log and observation browser and look up 1788. And so here we go then, somewhere in here, I should be able to find observation 1788. And just slide down. 1788, gone too far. Go away. There it is. Double click on that, and that should bring up the observation that I did, and these are the details here. I did it with the Skywatcher 120, the 5-inch there. I used a Teleview Ethos eyepiece, and there's the H32.5, which is also called NGC's 1788. Of course, all of Herschel's objects, 2,500, which he looked at, were all given a new general catalogue classification. So notes here, some bright nebulosity, but needs a bigger scope. And that's a theme that I had through a whole of these things, that you just can't see as much as you want to through the eyepiece. And record things like the sky conditions, the weather conditions. You can see it was 3 degrees when I was doing that. Dew point was 1 degree, so that gave a relative humidity quite high of 85%, but not too bad. And of course, whether or not I've taken an image of it, and that's the sort of thing that you can see for that. How are we doing for time?
Yeah, cut 2 more minutes. I'm really enjoying this, Trevor, by the way.
Okay.
Excellent piece of software.
So other objects now, as I said, I'd mention about the planetary nebula, which is the next one, 34.4, which is 2022, which is this one here. So and I'll go cancel that one, and then go into 2022, which is this one here. And there's the planetary nebula, which is a very, very tiny circular starlight object. It's a planetary nebula. Whereabouts is it? Well, we can go and have a look at that. Here we go back. Oh, we can't do that at the moment. I'll come back to that in a second. And just the details of the observation should come in here. So where is it? It's go in there, show chart, and it'll take me to the object. and a bit too high magnification. But if I zoom out, you can see it's in between Betelgeuse and Mesa. Now, we also had Bellatrix earlier on, and that's this star here as well. So it's in between these two. You can see there's a nice cluster of stars there, which gives quite an easy place to go to. From those stars, you can come along to these two and drift eastwards and then up a little bit, and there's the planetary nebula there. So that's
Wow.
how you use Deep Sky Planner for finding objects.
But you might need a bigger telescope, might you, Trevor?
Well, I don't think any bigger than a 20-inch. No, not really.
Excellent. Well, that is, it's a bit of a beast. What do you think Herschel would have made of Deep Sky Planner?
Well, I think he would have been very confused because he wouldn't have been able to plug it in because he didn't have any electricity. But I think
Oh,
he would have been absolutely loving it. But I mean, you saw on that observation that he had there, he had a name of I can't remember who it was, but it was a Frenchman who obviously had a look at it beforehand and reported something of interest in that object. That was Nebula 32, and so he then found out where that was, went to that position and had a look at it again, and then perhaps said, "Oh, I discovered that." I don't know, to be honest, but yeah, it's really good to see that these observations. I feel a little bit of a dinosaur now because, of course, with smart telescopes, you could go to NGC 2022, take a picture of it without even going outside. Just put it down, switch it on, and press a button, and you get the picture. But
dinosaurs are
seeing
good.
it physically is well worthwhile.
Yes, excellent. Keep on being a dinosaur in a world of
Yeah.
digital. So thank you so much. Right. Thank you, Trevor. We might come back to you if we get some time towards the end.
Okay.
Brilliant. So that was Deep Sky. What was Deep Sky Planner? Brilliant bit of software there. So we're going to go over to Chris now. He's in Oxfordshire. Hello, Chris. Good evening.
Hello, good evening. Thank you for inviting me on this running show.
It's been really good. Oh, David's joined us. David Arditi. I've just spotted him lurking in the bottom there. To know where. There we go. Maybe he's got some. Just come on a minute, David. Have you got any live views there?
No, there's slight gaps in the cloud, but no, not much. But I'm keeping a lookout, so if anything happens, I will let you know.
That is just splendid. Right, then it looks like we're going to go to looking for Mercury, one of my most evasive objects. I have stood countless times trying to find it on the horizon, screaming at the horizon that I must be going insane. And then when you spot it, it's just there in the sunset, a tiny little stable planet. And it's one of the most exciting things for me to see Mercury because it's such a little divil to find, isn't it, Chris? If you're not
It is, yes.
take it
So,
away.
right, let me just minimize that again. Okay, so one of the themes of National Astronomy Week has been the parade of planets that is currently in the evening sky, starting with Saturn, then Venus, then Neptune, then Uranus, then Jupiter, and finally Mars. But the planet that's been conspicuous by its absence in that lineup is Mercury. And the reason for that is that it's been in the morning sky rather than the evening sky. But that's about to change because tomorrow, as it happens, Mercury will be exactly passing behind the sun from our point of view, and then it will become an evening object again. And at the end of this month, there is probably the best opportunity for anyone to see Mercury in the evening sky that's coming up all year. So that's what I'm going to talk about this evening. So to start with a few basic facts about Mercury, it's one of the 5 naked eye planets, the others obviously being Venus, Mars, Jupiter, and Saturn. And it's been known about for millennia. We don't know how or when the first person saw Mercury and realized that there was something there that was not quite like a star. It's the smallest of the true planets, now that Pluto has been demoted to dwarf planet status. It's just under 5,000 kilometers. It's a very interesting object because it has a very large iron core, which is unusual. And the theory is that it may have been hit by something early in the solar system, which got rid of a lot of the outer layers and left behind just mostly core and not much else. It orbits the sun every day, every 88 days. Its average distance is about 1/3 of our distance from the sun, about 58 million kilometers. And that means, of course, it's getting very cooked by the sun's radiation. The distance changes quite a bit. When it's at its furthest away, it's 50% further than when it's at its closest. So there would be quite a variation in the amount of sunlight hitting Mercury, but the daytime temperature can reach about 440 degrees, which is hot enough to melt lead. And even that is not hotter than the surface of Venus, because Venus has this massive atmosphere of clouds and a greenhouse effect. So although Mercury is the closest planet to the sun, it's not actually the hottest planet in the solar system. From Earth, it never appears more than 28 degrees from the sun, which means you have to be rather careful when you're observing it. The best time to see it as a casual observer is in the morning or evening twilight, when it's at its greatest distance from the sun. And those times are generally in the west, in the western sky in the evening twilight on spring evenings, or in the morning twilight on autumn mornings. And the time that's coming up at the end of February is a spring evening, obviously. It doesn't feel much like spring at the moment, but I'm assured that spring will happen sooner or later. And this will be the best time this year to see Mercury. So this is a screenshot from the planetarium program Stellarium for the 26th of February. Looking west, you can see the W on the horizon there. And I've taken these screenshots and I've adjusted the time so that the sun is 5 degrees below the horizon in each of them. That's roughly half an hour after sunset, but you know, there's some variation around that. And the main thing you will see if you look in that direction is Venus at about 25 degrees above the horizon, incredibly bright and clear object, which we've been looking at for the last few months. But below it, and much closer to the horizon, at about 7 degrees, will be Mercury. And on the 26th, it will be 83% illuminated. It's on the far side of the sun, so it's almost full, as it were, like a full moon. But that will change, and it will come round towards the Earth on its orbit, and its magnitude, which is negative at this point, will drop until it becomes quite faint, as the level of the fraction of the illuminated part that we see gets less. So I've moved these on by steps of 3 days. So this is the 1st of March, and there is a very pretty conjunction because we have a thin crescent moon in between Venus and Mercury, which will look absolutely lovely. I would hope to see lots of photographs of that. I shall certainly be trying to take some myself. Mercury is now crept up to 9.5 degrees, but it's only 3/4 illuminated after those 3 days. And it's still fairly bright, and that will be a lovely triangle in the autumn sky. Sorry, spring sky, we're talking about. Venus, the moon, and Mercury. And I'm really hoping to see that myself. Moving on, you'll notice, by the way, that Venus is gradually moving down and to the right as we go through this. And that's because Venus is now coming in between the Earth and the Sun, which happens sometime in the middle of March. So Venus is moving back in towards the Sun. Mercury is still just moving away, and then it will start to come in as well. On the 4th of March, it's 11 degrees high, 61% illuminated, and it's got a bit fainter. If we move on to the 7th, you notice Mercury and Venus are now getting closer together. Mercury is now 12 degrees, half an hour after sunset, but getting a bit fainter. And there again, it's still, that's about the closest it gets to Venus. It's only 35% illuminated, and it's now plus 0.7 magnitude, which is significantly fainter. It'll still be visible, but it will be getting fainter. But Venus will provide a very good reference for you to find it at this point, because it'll be easy to spot. And the last one I've got here, Mercury just over 10 degrees, only about a quarter illuminated now, and getting much fainter quite rapidly. This is the 13th of March. If you're careful and have a good sky, you might be able to see it for a few days after this, but I suspect this will be about the limit. So if you see Mercury, hopefully you will at this time, what will it look like? Well, with the naked eye, it will look just like a star. Sometimes it appears pinkish in color. I've seen that myself, and I think that's just an atmospheric effect. If you look at it through binoculars or take a picture, it will still look like a star because it's very small in apparent diameter. It's about 1/180th of the diameter of the moon, These two pictures are taken by British astronomers. Mercury is actually there. If you can see my cursor, I think that's Venus. It might be Jupiter. I can't remember. And this one, the Pleiades are up here and Mercury is down there. Those are the kind of things you might get if you just take a picture with your smartphone or with a camera. If you want to see the shape or the phase of Mercury, you need to use a telescope. These are a couple of pictures which I stole from the internet, taken by a Greek astronomer using a 5-inch Meade telescope. That's a pretty average size amateur telescope. And you can see that in one of them there is a nice crescent. It's a bit fuzzy, but that's because Mercury is really quite small in apparent size. And in the other one, it's slightly more than a half phase. And those are the kind of things you might see with a small telescope yourself, if you have one. And it's worth looking for that because then you can follow the changes as Mercury moves out from the sun and the crescent, it gets more and more of a crescent and then starts to move back in. Just be very careful not to try and observe it while the sun is still above the horizon. That's really important for safety. If you use a larger telescope and do sort of video capture method that amateurs do these days, you can actually capture detail on the surface of Mercury. And this is one of my images, the one on the left, taken in that way. This is a stack of 5,000 video frames. The two images on the right are from the Messenger space probe, which went to Mercury about 10 years ago, 15 years ago. The one on the extreme right is the actual image, and the one in the middle is the one I've blurred dramatically to make it as bad as my image. And you can see there is a considerable degree of similarity between the two. The Messenger image is an infrared image. My image is also an infrared image. And so the features that I'm picking up there on the surface of Mercury are actually genuine features. They're not just artifacts of the imaging process. That's quite a difficult observation to make. It's not something that I would recommend to anyone who's just starting out in astronomy. You need to be a fairly experienced planetary imager. And even then, you will fail a lot of the time in making those kinds of observations. One final thing that's very interesting and that not many people know about is that Mercury has a tail, like a comet's tail. Now, this is an image taken through a filter that transmits the yellow light of sodium, which is the color that those old sodium streetlights are notorious for, that we hate, and the color you get if you spill salt in a flame of some sort. The reason it's like that is that the tail has a fairly high component of sodium, which has been blown off the surface of Mercury by the solar wind and by the fact that it's really close to the sun and very hot. And it gets blown backwards by the solar radiation pressure to form this tail, like a comet's tail. The length of that to the star in the middle where it more or less stops is about half a degree. That's the size of the full moon. And the dark strip at the right is a piece of filter which cuts down the light from Mercury by a factor of about 50. So it's not a huge overblown blob and you can't tell where it is. With a small dot like that, you can actually see where the planet itself actually is in the sky. Now, this is taken with a fairly complicated setup from the UK, but if you are in the right location, you don't actually need any of that.
Chris, I've just had a message off David. He's got live Jupiter, so we'll wrap up any moment now.
This is my last slide. This is my last slide.
Excellent. But I didn't know Mercury had a tail. That's my new favorite fact.
This was taken by Nick James, who's the director of the BA Comet section, from about 6,000 feet up on La Palma in the Canaries. And this is just a straight photo. Well, it's not a straight photo. It's a stack of 26 30-second images. And you can see it has captured the tail, a short length of it sticking up from here like that. So these last things are very specialized observations, which not everybody could do, would know about. But it's interesting to see that this kind of thing can now be done by amateurs. The final message from this talk, if you want to see Mercury, the best opportunity of the year is coming up at the end of this month. So if you want to see Mercury, go out in the evenings, look to the west at half an hour after sunset, and you will be able to see the smallest planet, one that's closest to the sun. Thank you.
That's just fantastic. Thank you, Mercury. So exciting to see. Right, let's see whether David's still got Jupiter. Fingers crossed.
Yes, I will be able to show you Jupiter through a 14-inch telescope. Should be able to see that now. It's
Fantastic.
it's coming and going. It's getting too bright now. Turn the brightness down. It's very poor seeing, rather jelly. Looks like a jellyfish moving around there because of all the clouds coming and going and different layers of air mixing. But I'm surprised it's cleared up at all because it's been pouring with rain. Well, not pouring with rain. It's just been drizzly and miserable all day. So what we see here is an inverted image of Jupiter, as is normal in astronomical telescopes, with south at the top. And there's two main belts which run parallel to the equator, the south equatorial belt at the top and the north equatorial belt, which is more brick brown, more intense and a bit wider. And then you've got other minor belts, such as here's a bit of the south temperate belt just there. And there's the north equatorial belt has quite a few white spots, there's storms. They are disturbances, they're material upwelling from deeper inside the planet and coming to higher altitudes, and the higher altitude material tends to look white. And so there's been quite a bit of activity on Jupiter. The Great Red Spot is around the other side at the moment, so I don't think we'll see that today. And you see the equatorial zone is this white area here, and you get darker plumes of material typically extending from the north equatorial belt into the equatorial zone. All these belts exist because you get different wind speeds on Jupiter. There are actually different rates of rotation, and then you get shears between the different latitudes which are rotating at slightly different speeds. That's where you get the interest in the material mixing up. And as amateurs, we spend quite a lot of time, or some amateurs spend quite a lot of time measuring the positions of the spots on Jupiter and tracking their drift, and that gives us clues as to how Jupiter's atmosphere is working, how the convection cells are working. And also, you'll notice although it's not very still, it's a bit like a jellyfish. Basically, Jupiter is an oblate shape. It's a flattened shape. It's not perfectly circular, which is because it's an entirely fluid body. It's mostly hydrogen. And so and with its very high rotation rate, spinning once in 9.5 hours, it's spun out at the equator. So it's the most oblate looking of all the planets. And it's very low density. Its density is only about 1.5 times the density of water overall, although we think it does get quite solid in the middle. It's probably a material called metallic hydrogen in the middle, which you cannot reproduce on the Earth. It only occurs at very high pressures. Jupiter is nicely placed in the evening sky and will be for a couple of months to come, really.
Hey, David, thank you so much for that excellent view. He's
Oh.
looking fantastic there. By Jove, look at him with his looking a bit wibbly wobbly. But if we go outside now and we wanted to see Jupiter, it's really high overhead at the moment, isn't it?
Yeah, you look to the south, if you can find where the south is, and it's 50 to 60 degrees up. It's at its best about now, really, about 8
Mm,
in the evening. And of course,
David, thank you. Trevor, sorry to cut across you there. I didn't mean to, but Trevor has got the moon live, so we're going to zip over
lovely.
to Trevor now. Thank you so much, David. We might come back to you. Could you get Mars, do you think, tonight, David?
I can try for Mars, yes.
All right, I'll see you in the chat. Let us know. Let us know. Right, we're going over to the moon, which is in my hands. Can't recommend these little USB moon models. They're brilliant. Really lights up the room. So we're going over to Trevor now, hopefully. Here we go. Oh, yes. Hello. Look at
Well,
that.
you can see the moon is very green. Obviously, still made of green cheese.
Delicious. My favorite type. What are we looking at now then?
Obviously, it's a gibbous moon we're looking at, and I just thought I just popped outside, opened up the observatory, and just got it in time, and we can see the crater Tycho here. That's this one here, and whereas we were looking at it a few days ago, you couldn't see any of the ejector rays. Now these are showing up really nicely, coming out from that. And some of these rays stretch quite a long way, probably a third of the diameter of the moon away. So rather a big impact, and it would have ruined your day had you have been there at the time. Let's have a bit of a zoom in onto that. I'll have to position my camera slightly, or I can move the telescope around. Come out of the way. You're in the way, Vicky.
Am I in the way?
No, I'll move you across. There you are, that's better. So we can have a go up a little bit. You're always going to go the wrong way, isn't it? Whatever you do. Come on down. Yes. So let's zoom in a little bit. I'll see if I can get that in the center. Which way? I'll go that way. No, it's always going to go the wrong way. There we go. And I'll just zoom in again onto that. So we go up to 50%, and then we'll go up to 100%. So the atmosphere looks quite stable tonight. A little bit of movement there that you can see. The telescope's outside all the time, so that helps quite a lot. This is Tycho here. So when you zoom in, you don't see quite as much. I'm not sure why it's drifting like that. It shouldn't be doing that. Come back. And so let's just have a look around. So this is crater Clavius, and this one, that's this one here. And we saw this earlier on in the week when it was just on sunrise, and in fact only these two craters were visible, and this one here, I think. And now the sunrise is almost complete, and there's just a little bit of shadow on this this side of the crater. And if you remember, I mentioned about seeing this circlet of craters getting narrower and narrower. And I think with this scope at this magnification, I can get to there. But if you take high resolution views of this and stack them, you can get all the way around with this same telescope. So that shows a little bit of degradation of the view with it being in a live fashion. Moving over to the Terminator, one of the things you can see here, of course, is that some of the craters are just partially illuminated with a lot of shadow on them as well. So if you were standing in the middle of this crater, you'd be completely in the dark, but you could be looking towards this horizon here, and you just be being able to see some sunlight coming through some of the edges of the side of the crater.
Okay, so David's got Mars now, and then whoever would like to go last, because we're going to be coming up to the last 10 minutes now. We've post in the chat who would like to come on last. I know we've got a Julian Onions presentation possibly as well. So just we'll go to Mars, please. Thank you so much for that. That was just so beautiful seeing the moon in real time and so close up. Thank you for the guided tour of the craters. Who's next? David, we've got Mars, hopefully.
There we go.
That's exciting. Hello, Mars. Like a bit like my sequins on my trousers. I always think Mars is like a sequin. So what are we looking at here, please, David?
Well, this is the same telescope as I was using just now for Jupiter, the 14-inch telescope with a Barlow lens. So it's very long focal length, about 4 meters focal length. And so this shows the true relative size in the sky of Mars and Jupiter. So you see, Mars is a lot smaller than Jupiter. It's smaller in reality, much smaller than the reality, of course. Jupiter is 13 times the diameter of the Earth, and Mars is about half the diameter of the Earth, but Mars is much, much closer. So Mars is about half the size of Jupiter in the sky, and this is when it's at its biggest. It's more or less its biggest that it will be for a couple of years at the moment, and it's already moving away from us, about 75 million miles away from us. And you can see some of the dark albedo markings. You can see in the southern hemisphere, you've got the Mare Erythraeum, which is this dark irregular patch, and there's this Mare Acidalium is this one here. This is the North Polar Cap, this white area, and that's visible in small telescopes. That's visible in 3 or 4 inch telescopes in good conditions. You have to magnify Mars a lot, but it takes a lot of magnification. Because it's a red object, it seems to always look quite sharp, sharper than Jupiter, and we've got it very high in the sky around 11 p.m. at the moment. So this is the best time to look at Mars for the next couple of years. Mars rotates about once in 24 hours, so you see almost the same view on subsequent days if you look at it as subsequent days, but it gradually rotates. We've got a slightly different view now to how we had on the previous broadcast, and actually seeing seems to be improving now. It's steadying down as the clouds disperse, and actually it's turning into quite a nice view now. So that's a stroke of luck there.
Oh, thank you. Just on the last couple of moments of the chat. So we're going to go over to. Thank you so much, David, for that. That's very exciting.
Well, I've rushed here on my bicycle from Astrofest, where I've been today.
Yeah.
I got here as quickly as possible.
Hello. Yes, hello to everybody at Astrofest, and well done for pedaling as quickly as you can.
Yeah.
Thank you. Right, I think we're going to go over to James now, and we're going to talk about the Nottingham Astronomical Society Observatory. Look at it there. Lovely. Take it away, James.
Well, it was great to see the moon and Mars and Jupiter. I didn't think any of that was going to be possible tonight.
Come on. Yeah.
So a quick tour of our observatory. The society was put together in the 1940s, but the observatory was built in the 1980s. And here you can see the lid, the dome being put on the brickwork. And this was an old grain silo. And here's the modern day view of the observatory. We have no mains electricity, so we use wind and solar to charge up batteries to drive the mounts and even boil the kettle. Here's a picture of some observing at night. This is when we had a recent comet and everyone was hungry to get pictures and to observe it. And we've got some lovely aurora pictures from the observatory from last year as well. Now inside the dome, we've got a permanent setup. For those who don't know, this is the pier, this bit circled in green, the pier, the tripod. This is very sturdy and it's secured to a concrete base below. And this holds everything nice and fixed and rigid. And on top of that is the mount. So this is an EQ8. And this is the brains of the operation. It's got motors and electronics, and it can point the telescope wherever we want, and it will track things in the sky. And then on top of the mount is the telescope. And like David, we've got a Celestron C14, which is the big scope, and a couple of little scopes, smaller scopes, attached onto that, piggybacked onto the back. And different telescopes are for different things. So the big telescope offers us really high powered views, high magnification views of things in the sky, and the smaller telescopes, less magnification, wider field of view. Bit of drone footage from Richard, our treasurer, shows the observatory and the dome and the slits open. So the slit opens and closes, and the whole dome rotates, so we can look at any part of the sky. And looking at this earlier, I wondered if there'd been a meteor impact onto the roof of the observatory. Looks like something splattered and exploded. So I need to explore that. Outside the observatory, there's other things. We've got this pier with a perspex dome on the top, and this is our all-sky camera. It's made up with various bits of Raspberry Pi, and it gives us views of the clouds above, and it works day and night. And last year we got some, again, it captured a lot of the auroral activity, which came a long way south in Europe, and was lovely to see from Nottingham. And hopefully that video is playing and you can see the reds and the greens.
Oh, them some good reds.
Yeah, and Callum was talking about the different colours of the aurora last night. We've also got these two cameras. They're not security cameras. They're meteor cameras, and these observe the sky throughout the course of the night. And this is a time lapse of one of those cameras from a few weeks ago. And you can see the Pleiades or the Seven Sisters here sweeping across the field of view as the Earth rotates. And there's lots of busy activity. Most of that is aircraft. And Orion, our favourite constellation of the night, is here. And we follow the belt up, and there's Aldebaran, and that's Jupiter there. And we'll skip over that. This is a summary of that video, and you can see it's a right mess. And most of those streaks are aircraft. And if we subtract the aircraft, then you can see the curved natures of the star trails, and also there's a lot of meteors have been detected. There's a really bright one here streaking across the middle of the field of view. And the software works out where all these meteors have come from. It tracks the path back to the radiant, the origin, and all that data is combined with other observers in the UK and further afield, and really useful work's done on observing known meteor showers and looking for new ones and other events which are less predictable. And that's it.
How do we get involved with the society? When do you meet? Tell us more.
Oh, we meet twice a month for meetings. First Thursday and the third Thursday. It's all on our website. And hold observing events when the ground's dry enough. It's a bit boggy up there at the moment.
Okay, James, thank you so much for that. Have we got Robin here? I can see there's somebody from the SPA down there, but I'd just like to say thank you to everybody for a bit. It's Robin! Robin, hi!
Hi there.
Oh, thank you so much. You've been at Astrofest. Thank you so much for
Yeah,
asking.
hot foot back from Astrofest, so I missed all the show, but I couldn't miss the last quarter of an hour, so I'm
Oh, Robin, thank you so
pleased
much
to
for
be
letting-
here.
Thank you so much for inviting me to do this. I've had the absolute best time. Really, really good. Plug for the society if you want to join the Society for Popular Astronomy. How much is it a month, Robin?
£27. Well, for it's £27 for the year. For that, you get
Sorry,
six
yes.
copies of the most wonderful magazine, Astronomy in Astronomy, which is Popular Astronomy magazine, of which I happen to be the editor.
Excellent, excellent. Robin, so have you got a couple of last words to say before we disappear into the ether?
Well, tomorrow we are talking about Mars, which is the planet of the year, really, because it's a special night tomorrow. I don't know if we will be able to catch this, but it actually is occulted by the moon, as seen from northern Scotland. And whether we can get this or not, we've got a team in Elgin. I don't think they'll quite catch that. You need to be north of Elgin and Aberdeen and places to be able to see it. But that's what's going to happen. Mars very close to the moon tomorrow night. So if you look out and it's clear, you will see that. Down here in the south, I don't think it's going to be clear. It's going to be cloudy and rainy. But any further north, it might well be visible. It'll be a lovely sight, Mars and the moon together.
So did you see that David got us Mars and Jupiter?
I heard you say that. I'm staggered because here in High Wycombe it's still raining as I got in from Astrofest, but I thought it might be. I did tell him when I saw him at Astrofest that it might just be clear, and we were dubious whether it would happen, but obviously it did. That's great.
That's wonderful. So we're going to wrap up now. Two things, Robin. Who's that there?
Who? What? Oh, Cosmo,
Cosmo, the
the
sloth.
well-known flower.
Star of so many Pop Astro lives, and best of all, I've got my spangly dancing pants on just for you. So, right, I think we're going to wrap up now. It has been a pleasure. Thank you to everybody who's made this possible. Thank you for Callum for doing the tech, James and Trevor and Chris and David, and to you, Robin. Thank you so much.
Well, it wasn't all my show, but I'm glad it went well.
It was
Goodbye.
Goodbye, everybody. Thank you. Clear skies, etc. See you all soon. Bye. Thank you.